What I want to do now is talk specifically about one alcohol, and that's ethanol, because it's something that we do commonly see being used in various products, so looking at sterilizers and looking at alcoholic beverages. And focusing on that in particular, what we know is that ethanol can be produced through a process known as fermentation. So what this involves is taking some type of sugar source, like glucose or table sugar, which is sucrose. It could be the natural sugars that we find in fruits, and we carry out this natural process of converting it into ethanol. We've got a balanced equation here showing you the fermentation of glucose. So glucose, with its molecular formula C6H12O6, through fermentation can produce ethanol, and it also does produce carbon dioxide. One of the important things to note about this is not just the balanced chemical formula, but it's also worthwhile if you note down what the conditions needed are. And I'm going to spend a bit of time talking about this. We have the conditions being sugar and yeast. We need to have warm conditions between 20 to 30 degrees Celsius. Low oxygen levels, so in other words, we have anaerobic processes or an anaerobic environment. And the solution must be slightly acidic, aqueous, and dilute. For the first condition, we need sugar and yeast. Sugar is essentially what will be undergoing fermentation, so that's why we need it. And yeast, which is a type of fungus, a single-celled or unicellular microorganism, can carry out this fermentation process. The yeast itself produces a type of enzyme called zymase, and this allows for the conversion of glucose into ethanol and carbon dioxide. The second condition is warmth, so between 20 to 30 degrees Celsius. And this is to just ensure that this fermentation carries out in the optimal temperatures for the yeast to operate. The third condition is an anaerobic environment. If we carry this out in aerobic conditions, so that's in the presence of oxygen, then our product ethanol can actually undergo a further reaction, and it can be converted into what we call ethanol, which is a type of compound called an aldehyde, but it can then further react and produce what we call ethanoic acid, which is a carboxylic acid. And this is often what makes your alcohols turn a bit sour and they go rancid, especially if they're stored and out in the open for some period of time. Finally, the solution itself must be slightly acidic, aqueous, and dilute. It needs to be slightly acidic to just allow for the yeast to work in their optimal environment. It needs to be aqueous so that this fermentation reaction occurs in solution. We need to allow for the sugars and the yeast to essentially mix and for this fermentation to take place. And the solution itself must be dilute. When the concentration of ethanol gets too high, it actually renders the yeast ineffective and they essentially die. And it works out that ethanol through this process can only be produced up to about a 10 to 15% concentration. Once it gets to that, the yeast themselves die. But you might be wondering, well, how do we actually increase the concentration of our ethanol when we're looking at alcoholic beverages? And we know that there are various types of alcohols like spirits that can have, above 30–40% ethanol in terms of concentration. So how do we actually do that? Well, it's something that we've actually studied before, and it's got to do with distillation. To separate the water and ethanol, we can carry out a distillation, and we can see an example of one set up here. We can imagine we've got our water and ethanol solution here, and we're going to separate them according to differences in their boiling points. So it turns out that ethanol has a lower boiling point than water, and it sits around 78 degrees Celsius. So as we heat this, you can imagine that the ethanol will boil off first. It will form a vapor, which then transfers and moves through to this section here, through to a condenser. This condenser will then cause the vapors of ethanol to condense back to a liquid, and then this is expelled into a vessel and it's collected, and it's what we call our distillate. So this will represent one of the so-called fractions of our mixture here. And this will occur to the point where you've actually boiled off all the ethanol and it's condensed and then it's been collected. Once you've removed all the ethanol, then essentially you only have water left at this stage. We can continue the heating process, but it's not necessary, and this we know will then eventually allow the water to boil off, to form a vapor, and then to condense and be collected. This concludes the video on functional groups and in particular alcohols. Thanks for watching, and I'll see you guys next time.